also present now together with Matthias a project that we worked on for the last 5 years, which is for us also kind of a peak of the development. I'm Professor Dr. Benjamin Dillenburger. I'm leading the research group Digital Building Technologies at ETH Zurich. Our focus is large-scale additive manufacturing, and we got a little bit the brief to combine the lecture also with industry's perspective. So maybe Matthias, you can say something about you.
Exactly. So also welcome from my side. My name is Matthias Leschok. I'm a former PhD student at DBT at ETH Zurich, and now I'm co-founder of a startup ETH spin-off that is called SAEKI Robotics, and we were fortunate enough to be part of the White Tower. What do we do exactly? How did we participate? All of this we will see during the talk.
Yeah, so we try to condense everything into our 3-hour keynote, so we have enough slides here. Between custom and serial, because we want to, probably you have seen already short videos of the project, we want to show a little bit behind the scene, the background, and highlight that it's not only a single additive manufacturing technology that comes into the play in this structure. So I take over the background, which I think probably we will hear many people talking about that. That's still omnipresent in our industry, in our discipline, that the productivity of architecture is not increasing. That doesn't mean we have to 3D print everything, but we need to further digitalize construction, further optimize construction in order to increase the productivity as we know it from other industry sectors. And especially when we're looking at concrete, then we can see in the last 80 years not so much development. People are still standing inside with wet shoes in concrete. Not everybody is working on the construction site, so there's a lot of redundancies. Of course, that's not completely true. There's dramatic development in concrete industry when we are thinking about new material mixes, but automation itself, as you could see in these 2 images, did not really further increase, and that's why we are here to present the work. And you all are aware of the environmental footprint of building materials, especially cement, so we need to learn to work more strategically with this material. The vision of our research group is digital process chain. Actually, I took this vision over from my PhD advisor, Ludger Hovestad. And we are still working on that, closing actually the digital chain between design, automated manufacturing, to the management of the construction site. For us, what is important, I would probably try to highlight it in the upcoming slides also, is that if we have the first part, computational design, robotic manufacturing, our goal should be also to create more performative architecture elements. We shouldn't just copy what we know already, but we should use these technologies to really add extra value to the architecture and infrastructure we are producing. And another important aspect is, of course, this left circle that points somewhere in the middle of nowhere. It's like thinking of what happens with buildings after their operation phase. That is part of the entire digital process chain. In concrete construction, formwork labor is a major part. That depends, of course, dramatically on what you are building. So this is actually an old statistic, but the more custom your manufacturing process is, the more effort you have to put into formwork labor, and that's what we are all addressing with additive manufacturing. And I found this interesting quote from the engineer architect Nervi, who already pointed out that for him, one of the limiting factors of this fantastic material concrete is actually this trivial technicality that he mentioned, besides the limitations of our mind, that we probably have to work on this in another symposium. But it's the preparation of wooden frames. So it's the limiting factor of concrete construction are the formworks. So we are also not the first ones investigating what kind of formworks could increase productivity in architecture. This is Thomas Edison. He also is famous for some other inventions, but he also proposed and developed systems to cast houses in a single go. There were indeed houses manufactured, and the motivation is similar to what we are facing today. He wanted to be able to offer more affordable housings, actually. That's not the approach we're following. We probably are all familiar a bit with this video. It's one of the first probably 3D printing processes in general, not only for construction, but one can also see it as the first printing process in architecture, concrete printing process. And it contains already many of the important aspects. So we have here now a formwork-free manufacturing method, people start to have fun on the construction site. It's not a hard labor anymore. A lot of things are automated. What didn't happen here back then, 1920 or 1930, is a digitalization. So this is limited to now circular constructions. But you can also see they build up massive walls. It's, I think, more for industrial applications, maybe. Quite early layered manufacturing. And we started to develop our concrete printing method now in a digital environment. And I always show this video because it shows that it's a long journey. And I think we have now really many people from the audience that 3D print themselves. It's a tough learning curve. A lot of failures. So this is more or less the state of our concrete printing 5 years ago, when we got the commission to plan a 3D printed tower. So that was an intense development so far. You're aware, main development, and that's what I think is exciting as an architect. It's an interdisciplinary discipline. So we research field. So we have to work together with material scientists. In our case, Robert Flett's group helps us to set up the concrete mix in order to increase the strength and the perfect timing to build up almost endlessly high then. We work together with roboticists, computer scientists, structural engineers, and that makes actually this field so exciting. One question we ask ourselves is, what should we print? And so far our research group shied a bit away from the idea, for example, to print single-family houses. That's not our vision, that we want to actually add more concrete into the world, but rather maybe think, okay, where would concrete make sense, or where can we really also harvest the full potential of this digital technology? So using the concrete where maybe it's a more structural demanding situation, using 3D printing methods when it's also about freeform. One of the first projects after we, I think this is more or less what we presented in one of the older beam symposiums, was the idea to 3D print ornamented bespoke columns. And that's a student project called Concrete Choreography, where our client back then, the same client as the tower, the Origin Foundation, gave us the project to design an outdoor stage. And the students developed here actually this vision of a digital process chain. So now in Grasshopper or processing, you design your column, you press print, and then indeed 2 or 3 hours later, you have a one-to-one printed column, something that is up to now still very difficult to achieve with a little plastic printer. So it's dramatic and very interesting that the scale-up of this technology works so smoothly with concrete printing. So that encouraged also to further investigate what are fields of applications of concrete printing. Another field we found interesting is maybe improving already existing systems, like this is a kind of a filigree slab, a prefab solution that can come to the construction site and be combined with cast concrete to create monolithic slabs. If you want to maybe optimize material performance, we can introduce vaulted geometry in such system, and that's where we thought about 3D printing. Now, how to print vaulted structures, especially if you have a large bandwidth. Here we borrowed from another ancient strategy, that's the Nubian slab system, where you build also layer by layer. So again, a kind of a 3D printing method, but you don't need support structures to create these domes. And when we bring this to 3D printing, that means that when we print in such an orientation, we can basically print almost endless long elements. That's what you cannot do when you print vertically because of the stability during the printing and usually also the robotic range. So copying this, bringing these principles together, filigree slab and Nubian vault, we could show that we can create an optimized custom slab system afterwards here filled with a monolithic layer of concrete that saves 20-30% of material in a very efficient manufacturing process. Now back to the bigger project, the Tor Alva. Our client is used to build towers. That was his construction, made from timber in the middle of a mountain pass. With a similar program, it's a theater venue. So our client, the Origin Foundation, tries to revitalize a village in the Swiss mountains, which is a bit dying. There's not so much farming anymore. There's also in this area no ski tourism, not major at least. And so he tries to bring in a future by activating it through culture activities such as dance performances. And that was one temporary installation which is teared down right now, and our tower project steps is basically the next development of this strategy. Creating unusual spaces for performances in an unusual environment to add extra value for the local inhabitants, but also with events that attract international audience and artists. So our location is just below this former tower project on 1,700 meters high. It's the little village Moulins, formerly 100 inhabitants, now only 12, so it's really a dying village. Maybe now it increased again because the development start. One of the development of our client was to save this ancient house by moving it, because some space was required for the pass road to Moulins. And he also renovated some hotels in this village, but also dedicated this area for a new performance tower, the Tor Alba. So the Tor Alba rests on an existing construction, and I will quickly guide you through the village. So we are now driving from Zurich to St. Moritz. In this perspective, the tower only appears in his full dimension when you are standing in front of it. When you are then further, when you're coming from St. Moritz, you see the tower in the village from far away. There it acts as a kind of a lighthouse. We are now on the 4th floor. That's the main event space, where you have an overview of the entire valley, the village, an audience space for roughly 50 people, and having access to a vertical spiral staircase. So for us, it was important that this will be a fully digital process to design it, that we use the printed concrete fully structural. I will later show a bit more about it, that we also show that we can reduce the material that we use for such constructions, that we even integrate rebar and design for disassembly. Now I will go a bit into detail. Again, it's a collaborative project with my colleagues from structural engineering, Walter Kaufmann and Robert Flatt from the material systems. You see a bit the development here from the architectural concept. It is a parametric branching column typology that is actually the only element that should define the structural system, but also the architectural atmosphere. And so we basically modulate this topic over 4 levels, from very massive columns that more or less create a darker first level towards a very filigree branching structure on which then rests the compression-only cupola, also realized in 3D printed concrete. What is also important for us, that we design this project in multiple scales. So we have an organic scale of the entire architecture. Then we have an organic scale of the individualized columns, these branching columns, and it goes down to the surface texture that is realized through 3D printing. And let me guide you a bit through it. So the tower rests on an existing base, people climbing from level to level. As I said, the view opens more and more. Each time it's a slightly different constellation of these columns up to the upper floor, the cupola space, which is over 9 meters high, so much higher than this space we are in right now. And the other function that this tower has is, besides hosting the events, is also really creating this light tower for attracting people to stop in the village. Multiple research is integrated into this project. We will focus really on the 3D printing part and the 3D printed formwork part of the connections. What is the constructive principle here? We work with prefabricating. We think that we can harvest the best potential of the 3D printing system that we have in a prefab scenario. That allows us to keep the construction site in the middle of the mountains to a very short time period with a small impact on the village. And the entire tower is designed for being disassembled without destroying it. So we can actually disconnect these elements through unscrewing the connections and could assemble the tower at another location. The tower has a building permit right now for 5 years. First prototypes, that's important. And you see that here we basically follow this common principle. we 3D print the shell, ornamented shell, and then we cast in a conventional way concrete inside that would then be taken into account as the structural concrete. That is the first demonstrator, first study of the development roughly 4 years ago. What we could show here is that the kind of connections we are using, the assembly, is really working for reuse. So the demonstrator was disassembled and now ultimately turned into a bus stop in the village. But we ask ourselves, is this actually really the best strategy for using 3D printed concrete? So is it okay to use it as lost formwork? We just add additional material. We should be more brave in our research development. So our ambition was really to create lightweight hollow structures across the different scales. You have seen the bigger scale that acts as a truss. We are in a seismic region, so we have a lot of horizontal forces as well. That's why the columns build also a spatial truss. But the columns themselves are also hollow. And so this would be the typical way of using 3D printed concrete in combination with casting. Blue is the reinforcement, and we wanted to bring the thickness here down to 20 centimeters. The system was developed together with our partners Concept Poncini and allowed us to scale up the construction. So maybe I show some sections here. This is integrated reinforcement, how we use it. The vertical reinforcement is added into very small channels after the completion, and the horizontal reinforcement is integrated while 3D printing. See here 2 robots working together. That is a collaborative research with a spin-off from ETH Mesh that were responsible to bend also these custom horizontal rebars. And together with another industry partner, Sindel, we developed this process where we would in parallel 3D print and add the reinforcement in a coordinated way. That allows us to keep the full speed of 3D printing, so we don't need to slow down and stop our 3D printing process. Still, a regular column could be printed in 2 or 3 hours with this reinforcement integrated while printing. This needed to be tested, so we could show that our system is as structural performant as a cast column element. Maybe another aspect of the tower is also the material-driven ornament, where we design a surface texture not based directly on defining the geometry, but instead defining the print path. And every single column is customized. Every team member designed its own column of the upper level, so we have in total 64 different column patterns. Now I pass over, so this was the direct 3D printing part. I pass over to Matthias to talk about the maybe most important part of the tower.
Exactly. So I don't know exactly if you saw earlier on the slide, but it's always promoted that this tower was created formwork free, and I'm exactly showing you what has officially never happened. So welcome again from my side. My name is Matthias, one of the founders of SAEKI Robotics. We saw already in the introduction very precisely, where the costs from concreting, why should we focus on concrete. So I will just dive directly into it. I said at the beginning we are an ETH spin-off, and this is our shop floor that we have developed over the last 2 years. On the left-hand side, we have 4 robotic units that are able to 3D print, let's say 2.50 m by 120 by 250. And on the right-hand side, we have a Zimmermann, that's a German CNC manufacturer. And we are focusing, or part of our focus is bespoke formwork for concrete construction. So how does this look like? So we are printing a net near shape out of thermoplastic materials. It's a regular 2.5D process. All of our machines are running on something that we call the SAEKI OS, our own operating system. And then we get this very rough, let's say 3 mm layer height shape. And then in a secondary step with a CNC machine, we can surface finish, we can add details, we can, be up to tolerances. And then depending on the industry that we serve, we can also create a digital twin of the element that we have created. This is something that we have not done yet for construction, but for other customers that is necessary. I said at the beginning the CNC process. So we first print, then we machine. The CNC process is essential, specifically for concrete casting, because then you're actually able to achieve these fair-faced concrete surfaces that you need. It's all about tolerances, tight fits, non-spill features, just to make these kind of things actually workable. What you see here is, I think, the very first formwork piece that we have done for the White Tower. It has now an edge length of 1.50 meters. Depending on the floor, we went up to 2.50 meters. And we do not only provide, let's say, the absolute minimum necessary when it comes to the formwork, but we also integrate engraving, holes for all the, functional things that you need to add to your precast element. We never cast ourselves. This is in collaboration with a company called Creabeton in Switzerland. It's one of the bigger precasting plants. And I think what we see here is that we only provide whatever is necessary, whatever you cannot very easily fabricate in a more traditional manner when it comes to casting. And that can be up to a single curved surface that can be very easily fabricated with a 2.5-axis CNC machine. I think this picture here shows two things. One is that we only print whatever is really necessary. So we have the surface that is in touch with the concrete, and then the rest is regularly just a ribbing structure that would allow you to cast, that would allow you to step on it, that would allow you to actually handle it with a crane. And then for sure the tower, maybe I should have started with what are we actually providing the formwork for? We spoke about the columns at the beginning, and we basically provided all the capital and all the bases for all the columns. So all the floor plates are basically cast into 3D printed formwork, and this is what we see here. And for sure, for structural reasons, there's a lot of rebar that goes into these elements. And then I think one thing that is super important when you deliver a product to the construction sector is that it just has to work with the regular work line that they are doing. So our formworks are approved to be hammered into position with a hammer if you have to. You can drill holes into it, you can step on them, and you can also cast any kind of concrete into them. So whatever we see here is the absolute regular process for casting these precast elements at Creabeton. And another aspect that I think is important to mention is that we delivered one formwork for each floor, because you can reuse them up to 100 times if you have to. For the White Tower, it was now the case, I think, 6 to 4 casts per element. And I mean, these things are quite huge. I think they have like 5-6 tons depending on the floor. And you can see all these, I don't think you can see it on this image, but it has all these engravings that will later then facilitate a very easy assembly, because no one needs to look at the plan, because you can simply guesstimate where things need to go. I think when we speak about prefab, and if we start stacking prefab elements on top of each other, one aspect is tolerances and fit. And I have to say, as far as I'm aware, all of these elements fit quite nicely together. And specifically, I think it's interesting to see that maybe another view behind the scenes, there was never time to actually do a prototype of this constellation that we are presenting today. But magically, I think as we are based on this digital model, it doesn't matter if we concrete 3D print in one facility or we provide a 3D printed formwork. For a precast, these elements, if we all stick to our nice 3D model, we are actually able to create elements that basically seamlessly fit into each other. And I think one of the last slides here is we have provided formworks from the very first to the very last floor. That's from the level 4 looking upwards to the ceiling. So all of these elements are precast using a single formwork. And then, yes, we do use thermoplastic materials to create formwork for bespoke concrete structures. However, I think this can happen in a meaningful way. I'm not trying to greenwash what we are doing, but I think there are 3 aspects that are important. I think the very first one is these elements have a very high degree of reusability. So in this case, it was 8, but we have clients that are using our formworks up to 100, 150 times. The second aspect is wherever we can, we directly source already recycled thermoplastic materials. And step number 3 is we do not recycle ourselves, but our material providers actually offer you the option. We print, we buy material, we do our thing, we give the formwork back, they clean, shred it, and we can buy recycled materials again from them. For sure, this doesn't work in an endless loop, at least with the materials that we have right now at hand, but I think it's the right approach compared to the alternatives non-standard, formwork construction has. And then, yes, we did the White Tower. It's an amazing project, and we took then all these learnings that we had, and start to serve the German, Swiss, and also very soon the UK market. So what you see here is a 3-meter tall column, actually made out of 4 elements. It has all the features that you need, so you can literally just pop it together, ram a few dividucts through them, and actually this is going to be used, I think, 120 times to create bespoke columns for a construction site in Switzerland. Another thing that we are also fortunate enough to be part of is the renovation of the train station in Lausanne. It's exactly the same process. We create a net near shape, we 3D printed. Actually, here we, I think, delivered 13 elements, that's over a ton of plastic. And our robot was literally printing 24/7 for 7 days. We printed an object, AGV came, popped in a new print bed, we printed again, we printed again. So I think it's this kind of, what we focus on at SAEKI is also being able to automate anything possible, so we can, create these, can get the same experience with a Prusa printer, but just way, 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 way bigger. And then I think, I was speaking now a lot about these very durable, very heavy-duty formwork systems. However, at SAEKI, we also have the opportunity to print differently. This is something that I've developed during my PhD, starting in, 2021, made a patent on it, 2022, and it's about printing tubular structures instead of solid sections. And this allows us to be super material efficient, but also change the scale at which we are printing at. And how does this look like? I think this was in the very first facility that we had at SAEKI. This was a column that we printed, was designed in the MAS DFAB program back then at ETH Zurich. And SAEKI started printing these kind of columns. We were able to print them not as fast as concrete, but close to. So that was just printed below 4 hours, has 9 kilos, and has, if you would cut it, the line width, or like your actual plastic, would be below 1 millimeter. And I think it's interesting the kind of texture and resolution that you get. It's very actually comparable to concrete 3D printing. Unfortunately, we were not able to integrate this into the White Tower. I know that was the ambition, but we were not there back then. Exactly. So let's look at this column very quickly. It's over 2 meter 10 tall, has a layer height of 20, a wall thickness of only 1 millimeter, and we were able to cast absolute regular concrete inside of it, which I think if you compare this to all this research that's going on at ETH, where you either use a sand bed to counteract hydrostatic pressure, or you use a very specific concrete mix to actually hydrate while you cast, that is a very nice alternative because you can use any kind of concrete. Here you can see a section of the cast column, or at least through the formwork, and as we're printing ultra thin, so that's literally below 1 millimeter, the demolding is actually quite easily. You get actually the negative imprint of concrete 3D printing, which is very specific. It has a very strong contrast when it comes to the shadow play. And as we're using absolute regular concrete, we can also start post-processing these surfaces as we wish, as industry knows it. So for instance, sandblasting it. And I think I just wanted to highlight that these 2 options of 3D printed formwork that I see working at a construction scale. I think the first one is this durable, repeatable, multi-step process where you have to cast 10, 150. This is what we saw at the very beginning. And here we can offer a solution that we can print fast. It is not as accurate maybe because of just this very low resolution that you're going at, but you are able, to facilitate a lot of volume, cast regular concrete in this kind of one-off fashion. Exactly, and I think with that, I hand over again.
I try to wrap up a bit. So we've seen next generation of formwork. It fits to the form next. Maybe to wrap up here, with this combination of one-of-a-kind 3D printed main column shafts and the cast formwork, we were able to design this tower as an assembly of multiple prefabricated elements. The cast base was fabricated in regular formwork system, and you see how much effort this was then back then. Just some snapshots from the manufacturing. Unfortunately, our columns, you cannot carry them on the shoulder, as Matthias showed, the plastic columns. These are the columns from the highest level, in this case, 6.5 meter tall when assembled. If you try to do a similar project, think about the 6.5 tall rebar rods that you have to bring in. So you need actually 30 meter roof height in your construction hall. This was all assembled next to the construction site, so there's no tunnel, which we have a lot in Switzerland. There's no tunnel in between. Those still had to be transported horizontally. They are post-tensioned, the only ones that are post-tensioned in order to for the horizontal load case during transportation. An important aspect if we go large in 3D printing. Stair comes later. Next concept would be to work also in mobile setups to bring the factory directly next to the construction site. And here, maybe as a wrap-up, the inauguration of the tower, which happened this year in summer. You see in this illustration very well how the structure branches out. The higher we get, the less force, less structure we need. Again, this tandem of two robots collaborating with each other. The assembly then of all the parts. One level requires roughly 1 to 2 days to be assembled. This was the idea, this opening scheme was the idea of our client who comes from the theater. I'm not sure if we can repeat that for larger buildings. And the opening which shows also how then this upper space would be programmed. I skipped this video, maybe just to find my closing remarks. You see the upper space, Matthias showed the perspective towards the top, towards the sky. Here you see it from the sky as an event location. Now there are events during the summer. The tower also acts as an outdoor stage, as a lighthouse. We could show that we optimize material, we increase automation, provide also a cultural space for the population and a perspective for the future. It's a big team, many industry partners involved. That makes these large-scale demonstrator projects so interesting, because this know-how transfer doesn't go only from academia to research, but also from academia to industry, but also the other way around. 3 startups of ETH are involved. Anton Reiter, they consult about large-scale 3D printed projects, and they really have experience with that, I can tell you now. A mesh that was involved in the automatic rebar, and SAEKI with the 3D printed formwork. Yeah, and I want to maybe close just with this vision. Bringing all this together helps us to move towards a digital building culture, and I'm very excited to be part of this symposium and looking forward for the next presentations. Have a fantastic day today.
Thank you.
So thank you very much. Matthias, I'm already a huge fan of the surface of that negative printed pieces. So it only took one picture for me to be a fan of that. Any questions from the audience? There's one.
Okay, maybe not a technical question, but since it's a small village, you said 12 people, right? Probably mostly elderly people. Was it well received by the population? Like, what they think about it for them must be very sci-fi, this kind of building, right?
It's an interesting question. First of all, in Switzerland, in these different cantons, these are projects that usually you vote for it. You have a direct voting system. So indeed, the majority that includes the entire valley was like there was a discussions. We presented the project multiple times. The client presented it, and ultimately there was a strong majority towards this project because the benefits. It creates another attraction in the valley. Now people stop by, they go to the local restaurant, so there's new jobs in the local restaurant. The hotel is activated. Before there was no one staying there anymore. Now there's 20 beds or 10 beds open. So it brings a lot of change, and obviously this is also a discussion then in this village. So there, I think not everybody would vote in favor for this, but this is probably what we all know in construction projects. You change something. I think the strategy of the client is that a major part of this village is really just protected, renovated, and kept, and now made to last again for another 100 years. And he tries to find the right balance between these kind of preservation strategies and also adding something new that shows that there's also a perspective to the future. Having said so, this is a 5 years project. In 5 years, we will see how is the acceptance after 5 years. Then we could dismantle it, or maybe the population again votes for it to stay there for a longer time. But so this is really the context of the.
Thank you.
Sorry for the stream.
Could you please repeat the total height?
The total height, including the base, is 30 meters. Yeah. 30 meters, yeah. So I think to our knowledge so far, it's the tallest 3D printed structure. Yeah. That was not the main ambition, but of course I have fear of heights, so I feel a bit dizzy when I'm up there.
Thank you for the talk. You have probably explained it, but I missed it. In the tower columns, did you cast concrete in there, or is it the printed concrete that carries
so
the load?
that's then I really did not communicate it well, because that is one of the major achievements from the scientific part, that we basically managed to reduce the amount of cast material to a minimum. So only in these 4 centimeter vertical channels there's then a cast mortar that connects the vertical rebar with the 3D printed concrete, and all the rest stays hollow. In the first prototype I showed, that was different. So there basically the percentage of cast material to printed material was rather 80% cast, 20% printed. Now I would say we have 80% printed and 20% cast maximum.
Okay, thank you. And one question to SAEKI. Are you facing any challenges in unforming, taking the formwork away of the cast slabs? Because sometimes formwork almost sucks into the concrete.
I mean, not trying to put... no, in general, no. I think the surface finish that we get is pretty good. You still need your off-the-shelf release agent to actually demold something. There were some parts of the design that were close to being an undercut, and that for sure you cannot demold. But there was some angle grinder loft that would basically just even these out. And then, you would do business as usual for these areas. You would put on a wax instead of oil. It's this kind of casting know-how that Crea Beton brought to the table.
Thank you also from me for a great presentation. What I was wondering is, did you do a comparison of classical columns compared to the 3D printed columns, and how much you have saved? Like, let's say we build the same thing with conventional formwork, conventional columns, what their dimensions would be with reinforcement, and how much you have basically created as a, let's say, saving in terms of material and rebar.
So that's of course also a very relevant question. So maybe to clarify, also we have here now a demonstrator, and here we of course also try to reach the limits of what the construction can do. The typology of the Y-shaped columns is actually, if we wanted to recreate this with a conventional strategy, it would have been almost unaffordable, because we would need to mill formwork for every single column element and then the hollow formwork on the inside to keep the material out. So if we would then assume we would have massive columns, then we would very likely have 80% more material in the column parts. Now, what we also tested is to what happens if we print conventional columns. And also there we can say we are competitive. We are faster to fabricate them. And also there we save material. But it's important to understand that this is to maybe clarify the question also, we would not need 8 columns to carry the entire one level. So of course here the columns are also the creator of the atmosphere, part of the architecture. So it's not that we can say this tower is the lightest tower possible, because it's really a double role. But in other projects we just emphasize on the material reduction, and there we can show that we are outperforming the conventional concrete. The next development is actually to improve also the material mix that we are used to even work with recycled aggregates and so on.